Alright, so we're going to be going over the solution to the 14th problem in the grind 75. This is implement queue using stacks. So basically what we have to do is create a queue or the functionality of a queue using two stacks. And we have to support these methods specifically. Let me comment this out. Pushing, popping, peeking, and empty. And before we go over those, let's just refresh ourselves on what a stack and what a queue is, what their differences are. So essentially, a stack is a data structure that takes in objects and pushes out the last one that was added. So what I mean is, say we just start adding objects to this data structure. We have 0, and then we add 1, and then we add 2. Well, if we want to remove from this data structure, we will remove from the spot that we added the last element to. So we would remove 2. So 2 would leave, and then again, if we want to remove, we would remove from the top. You can kind of think of this as, literally just like a pile of papers. You add to the pile by putting pieces of paper on top, and then you remove from the pile by taking the pieces off of the top. And then a queue is essentially just a line. When you stand in line, the first person goes in front, and the second person goes behind them, and so on. And then the first person to be serviced is the first person that was in line, and so they get removed. They get removed first. So it would be this that gets removed first. Okay, and that is the difference between a stack and a queue. And we are tasked with coming up with a way to implement a queue using two stacks. So what I did when I was doing this problem was just think about what happens when we start adding values to a stack. And that seems to be okay, but as soon as we need to have the queue functionality of push, we can't just, pop, we can't just pop off of stack 1 because that will not return the proper value. What we want out of a queue is for the first value to be returned. So the way to do this with two stacks is to take everything that's here and then flip it on its head. And we do that by popping off the value on the stack and then adding it to our second stack, which is really far over there, but we're going to put it right here. And then we continuously do that until this first stack is empty. And now we can pop the appropriate value. And that's how we will get that queue functionality. So that is a key insight. Another key insight is, say we have maybe these values. So we've pushed twice, and then we want to pop. So we are going to add 1, and then we're going to add 0, and then we would remove everything that's here. One thing that I sort of got stuck on was what happens when we push another value. So we push another value, say 2, but then we want to pop that. Well, all we have to do is look at our second stack and see that there's still values left to be popped. So we pop them off before we even have to push this. So that's basically all you need to know for implementing a queue with two stacks. We'll go over the actual implementation right now. So let's switch over to the LeetCode window. So the first thing we need to do is create two stacks. I just named them stack 1 and stack 2, as I did in the illustration. So and we're going to take integer values, 1 through 9. This one's going to be called stack 1. And the reason I'm doing it like this is because I want to define these stacks as public so that when we call methods on our new queue object, we don't have to, let's see. When we call methods on our new queue object, we can just call them without having to worry about access issues. If we were to just instantiate it like this, stack integer stack 1 is equal to new stack integer, like that, we wouldn't be able to access this because we don't know what permission we have for it. So we're going to define those out here. We could also just globally define this right here without even worrying about that, the constructor. But I'm going to do it like this, just so things are clear, and then same for stack 2, new stack integer, like that. And again, for pushing, we can pretty much do the same things that we would do for stacks. And all we're going to do is push to stack 1 as normal, given the value. And when it comes to popping, then we have to perform that flip, and also when it comes to peaking. So in order to prevent ourselves from repeating ourselves, we're going to push that logic out here. And what we're going to say is, for as long as stack 1 is not empty, we're going to push. We're going to pop off of stack 1. So let's make sure it's stack 1. I'm going to call it new entry. It's going to be equal to stack1.pop. And then we're going to push onto the second stack. And what that's going to do is pop everything off and then flip it on its head so that when we pop off from the second stack, it'll act like it's a queue. And let's make sure to add it to, what is it? The second stack. You're going to just push new entry like that. And all we have to do is check if stack 2 is empty. If it's empty, then we're going to want to perform this operation. And I'm calling it push to 2, as in stack 2. If it's not empty, then we can just pop off of stack 2 as normal. So we can do return stack2.pop. Okay, and then it's the same idea for peak. If there is no value in stack 2, then we'll have to load it up. Otherwise, we can just peak as normal. And for empty, if there are no values in either of our stacks, then we know that we're empty. So we just have to make sure to check both stacks for values, because there might be the case where stack 2 has values, but stack 1 doesn't, and vice versa. And our queue still would technically have values, because when we're pushing to it, we're adding to stack 1, but when we pop or peak, we're putting to stack 2. So really, stack 1 and stack 2 are all part of the same data structure, and so we have to check the whole thing to see if it's empty. And so we're just going to do is empty and stack 2 dot is empty. And these are all built-in methods for stacks. Stacks and queues share similar methods. It's just that we had to use the stacks. We had to use stacks to implement queues. So that should be the right answer. Let's just run this to make sure we don't run into any syntactical issues. Okay, I have to call the function. And I forgot to do that here because I copy pasted. Let's see. Okay, that worked. So let's submit. Okay, and that is the correct answer. So I'm just going to go over what I messed up in my attempt. So I had this exact thing, um, except for this right here. I had this statement right here. And to be honest, I'm not completely sure why this didn't work. So let's look at pop. So my logic was, if we have something in stack 2, then we will want to return that. Otherwise, we're going to want to push everything to 2 and then call pop again to return that value. That also required me to have this extra return statement down here, which, because of the problem description, would never get triggered because all of them would be valid, and so all cases would fall within these. But I'm not exactly sure why this didn't work. I guess something to keep in mind is that we want to keep our code concise and we want to condense logic as much as possible. So possibly thinking of this in a different way, in this way, for example, might help to alleviate any issues that we have. So yeah, if anyone knows why this didn't work, please let me know in the comments why this didn't work. So yeah, I'm going to wrap up the video there.